We'll proceed in innovative approach in calculus and cross Jacobian. That is something that we have invented. Cross Jacobian. What is cross Jacobian? I believe Jacobian is known to everyone. What is Jacobian? I thought I would complete this cross Jacobian, but anyway, prior knowledge of Jacobian is required. So, what is Jacobian? If we see, okay, so if we see kind of uh, like we were in phase of calculating the surface area of a sphere. So if I have a sphere, then what is the surface area of the sphere? That is under question mark. So surface area of a sphere, if I want to calculate, then it is analogous to calculating the curvature of a circle. If I have a circle, then what is the perimeter of the circle? What is the length of the line that is along the boundary of the circle? So that is something that is similar as if I have a sphere. Okay, I'll get back my sphere, very big sphere. Okay, this is the sphere that we keep on talking about. So this is the sphere, and this is the oop, oop, oop. This is the sphere. This is the sphere. Doesn't look like a sphere, right? But I'm considering this is a sphere. If this is a sphere, then this is circle. I mean, I'll make it a circle. So now, okay, so looks like it is not that easy to make it a circle. That somehow I have to do it. Okay, we made it. So this is a circle. If this is a circle, then this is the sphere. What is similarity between the circle and the sphere? If I talk about the perimeter of the circle, if this is the circle, then this is the perimeter of the circle. And perimeter of the circle is similar to the surface area of the sphere. Okay, the perimeter of the circle is similar to the surface area of the sphere. Okay, how we can calculate the perimeter of the circle? Now we have seen to calculate the length of the perimeter, we have to go with the vector. With simple algebra, we cannot calculate the perimeter of the circle. So we have to go with the vector. And in the vector, I have to find the tangential vector. Okay, so okay, so if there is any point x comma y here and it is centered at the origin, then this is the position vector of the point x comma y. If I say what is this is point P, then what is the P vector, that is position vector? Xi plus yj, or x comma y is the position at that point. If that is true, if x comma y is a position at that point, then what is dp by dx? Okay, for differentiation in position vector, dp by dx. So dp by dx, that is the gradient of the position vector. I am not saying gradient vector, gradient of the position vector, differentiation of the position vector with respect to x. So if this is position vector, then dp by dx is perpendicular to this position vector. We have proved it. If there is a curve, I'm not talking about a straight line. In a straight line, gradient of a position vector, gradient, if I have a position vector, then gradient may not be perpendicular. Okay, typically the it will see it. But if it is a curve, then if I have a position vector, then gradient vector will be gradient vector, gradient of the position vector, whatever gradient, if we calculate, it will be along the tangent of the curve. If I have a straight line, if I have a straight line, then if I have a position vector, then gradient vector will be tangent to this. That is nothing but along this line only. I believe it makes sense. Okay, if I have a vector that is a straight line, if I have any point, if I have a position vector, and if I calculate gradient vector, that will be tangent at any point. At this point, what is the tangent? Tangent is like this. It is along this line only. So the gradient of position vector for a line is along the line only. But if I have a curve, if I have curve and if I calculate the gradient of position vector, it will be along the curve only, but it looks like a tangent. Actually, it is along the curve only. It looks like a tangent. So if you want the length of a curve, then I have to find a vector that is tangent at any point. That vector is also, we can call it a length vector because it is tangent at any point. Now, I would say along the line. So, if I say that gradient vector of this line is tangent at any point, that is along the line only. Okay, so if I have a vector, so if this is a line and if I have a gradient vector along this line, then I can remove this line. The gradient vector, gradient of a vector, position vector is along the line. Now the gradient of the position vector represent the line. Gradient of the position vector represent the line. Okay. Now I can do, since it is in same direction, then I can do manipulation computation over the gradient of the vector, and I calculate the length of the line. That we will see. So here, if I have a curve, then at any point along the curve, I have a tangent, that is gradient vector. So if this is position vector, if this is position vector, then this position vector gradient differentiation is this vector that is along the curve. Now, if I have a gradient of the vector along the curve, then this vector, if I calculate the magnitude, if I calculate the magnitude and then integrate it over the full curve, it will give me the line length. This is what we have seen. Similarly, if I have a sphere, if I have a sphere and I want surface area, okay, if I have a sphere, now take any point P here. Now I cut xz plane and I cut in yz plane. In xz plane, if I cut, it will be a circle. In yz plane, if I cut, it will be a circle. Okay, both circle would be perpendicular to each other, guaranteed. If I cut something at any point, if I cut something, so if I cut in xz plane and yz plane, so consider that I cut in xz plane. Then this is the point I was talking about on the sphere. If I cut in yz plane, then this is the yz plane. Circle again, and this is the point there. If I cut in xz plane, this is the point here. Now at any point here, at any point here, this is the position vector. Okay, at any point. This point is common if I go in the yz plane. Now if I have a vector, if I have a vector that is along this xz plane, along this circle in xz plane, and I have a vector, that another vector that is along the circle in yz plane. Okay, if these two vectors, this vector and this vector. So if this is the point I'm talking about here, if this is the point, this vector and this vector. Can you see? This vector and this vector. If I combine these two lines, this vector and this vector. Okay, so it is something like this. Okay, if I make a cross product of these two vectors, then in this plane it will give the area of the parallelogram. But since they are perpendicular to, looks like they are perpendicular to each other, I believe so, then it will be area of the parallelogram or whatever it is. Between these two vectors, I get the area if I do cross product of these two. Otherwise, if I take only one that is in xz plane, and integrate over the full, I get the xz plane, whatever the circle circumference is. But at any point, if I have this vector and y in yz, these two vector if I have, and if I calculate the cross product of this, I get the surface area. Okay, whatever surface area I get, whatever surface area I get, that is the surface area. If I integrate with the xy plane, here whatever the vector I am getting, if this vector I integrate along the x-axis dx, I get the full circumference. This is what we saw. If I get a surface area crossing this vector and integrate it along xy plane, dx, dy, then I get the full surface area. Meaningful, right? Analogous to the circle only. So this is how we calculate the surface area of the sphere. I get two tangential vector in xz plane and yz plane, make a cross of it, and then integrate with the dx dy, you get the full surface area. Okay, what is the tangent plane? Now, if I take the sphere back, if I take the sphere back, and what is this? If there is a point P here from the center, this is centered at the origin. Point P here from the center, if I draw a line from center to point P, that will be position vector at any point P. At any point P from center, if I draw a line. Okay, if that is any point P, the tangent here in xz plane, this is x-axis, this is y-axis, this is z-axis. In xz plane, the tangent will be, if this point is P, then the position vector is xi plus yj plus zk, dp by dx. And tangent in yz plane is dp by dy. Okay, this is position vector. The way we did in circle, right? Please watch the previous video. How we calculated the circumference of a circle. If I have a position vector of the circle, then dp by dx, simple dp by dx, that talks about the tangential vector. Get the magnitude and integrate over the full circle. Now dp by dx, one vector. Up, up. Okay, so dp by dx, one vector, and dp by dy, one vector. If I take the cross product, I get the surface area. This I have to integrate with the full dx dy. Okay, dx dy means if I have a surface, what is the impression of the surface on xy plane? That is a circle. I mean, it's all right, right? So if I have a surface, if I have a surface, what is the impression of this surface on xy plane? There is a there is a there is a circle. Okay, so I have to integrate in the region on xy plane, that is a circle. dp by dx cross dp by dy and integrate with dx dy, and limit is along the circle. Okay, now why we need cross Jacobian, that is the question. dp by dx cross dp by dy, dp by dx cross dp by dy. For a sphere, the position vector is xi plus yj plus zk. dp by dx, that is I plus dz by dx k, cross j plus dp by dy, j plus dz by dy k. This cross will come minus dz by dxi minus dz by dyj plus k. Okay, if I take the magnitude, then dz by dx whole square plus dz by dy whole square plus 1 square root. If that is the case, then sphere is x square plus y square plus z square equal to a square. That is the equation of the sphere. In that sense, z equal to square root of a square minus x square minus y square, dz by dx whole square. That is minus x by square root of a square minus x square minus y square whole square, plus minus y by square root of a square minus x square minus y square whole square, plus 1 square root. If we settle down, it will come as a by square root of a square minus x square minus y square dx dy. Now we know that we cannot calculate this. It is beyond our mathematical intelligence or mathematical capability that I can integrate a by square root of a square minus x square minus y square dx dy in multivariable case. Then we go for method of substitution and we substitute x by r cos theta, y by y as r sin theta. Okay. Now we are now x equal to r cos theta, y equal to r sin theta. Earlier we had z equal to a square root of a square minus x square minus y square. Can you see something here? Z is dependent upon x and y. Z equal to a square root of a square minus x square minus y square. Now x and y are independent to each other and z is dependent upon x and y. Now x equal to r cos theta and y equal to r sin theta. Then x is dependent upon r and theta, y is dependent upon r and theta. So at the end, what we are getting? We are getting something as two layer of this is the way calculus proceeds. Two layers. One layer is theta r plane. Another layer is xy plane. On xy, there is a z surface, the sphere surface we saw. So this is xy plane on top of which we have a sphere. Okay, if this is xy plane, then on top of it we have a sphere that is z. Z is dependent upon x and y. And this x and y is dependent upon theta r plane. Z is dependent upon x and y, surface is dependent upon x and x and y is dependent upon theta and r. Okay, x equal to r cos theta, y equal to r sin theta. Where if this is x, then z equal to square root of a square minus x square minus y square. If that is the scenario, if that is the scenario, then we are calculating dp by dx cross dp by dy. Okay, and its magnitude dx dy. It came as a by a square root of a square minus x square minus y square dx dy. Dx dy is nothing but dxy plane. Like if I had a circle, then dx was x-axis, d of x-axis. Like dx dy is d of xy plane. If that is the case, then if I substitute x equal to r cos theta, y equal to r sin theta, then it is a by square root of a square minus r square. Cos theta sin theta will go away. A by square root of a square minus r square. Dx dy. Dx dy, how I can represent it theta and r. Dx dy is nothing but dxy plane. Dxy plane. Dxy plane I can write as dxy plane by d theta r plane into d theta r plane. So dxy plane by d theta r plane, that is new term that came into d theta r. D theta r plane is d theta dr. D theta dr. Now we have full expression as a by a square root of a square minus r square dxy plane by d theta r plane into d theta dr. What is dxy plane by d theta r plane? This is also called Jacobian. Okay, so probably we will see in next session because I am kind of I have a dire kind of sense, okay, dire eagerness to talk about the cross Jacob. So probably that we will see in the last session. Probably that will be the last session. Now, in that sense, what is the dxy plane by d theta r plane? This is called Jacobian because that is extra that has come because a by square root of a square minus x square minus y square, x equal to r cos theta and y equal to r sin theta, that nicely I converted into a by square root of a square minus r square. And dx dy and nicely I converted into d theta dr. Extra thing came as dxy plane by d theta r plane. Now, as per the Jacobian calculation, we will see how to calculate Jacobian. So as per the Jacobian calculus, this is nothing but a matrix dx by d theta, dx by dr, and bottom row is dy by d theta, dy by dr. If this is the matrix, then I have to calculate the determinant of the matrix, that is dxy by d theta r. How it is, that we'll see. If that is the case, then x equal to r cos theta, y equal to r sin theta. Okay, dx by d theta, dx by dr. So dx by d theta is minus r sin theta. Dx by dr is cos theta, minus r sin theta, cos theta. Dy by d theta, r cos theta. Dy by dr, r sin theta minus r sin theta. That is minus r sin square theta. Here again minus r cos square theta. That will resolve as minus r. Jacobian, we have to take the absolute value r. R is the Jacobian. So net integration is a by a square root of a square minus x square minus y square and then r d theta dr. If that is the case, now I have to go ahead with the integration. Okay, so it came as a I can keep outside r by a square root of a square minus r square dr d theta. Now integration limit, since on the xy plane I have a xy plane, the region is a circle. Region what we are talking on the xy plane is a circle where x is from minus a to a and y is from minus a square root of a square minus x square to a square root of a square minus x square, because it's a circle. If it is a circle, then x and y cannot be independent of each other. Unfortunately, they should be independent of each other. Then x equal to minus a to a. If there is a circle on the xy plane for the limit region, if there is a circle, then x is minus a to a and y is minus square root of a square minus x square to plus square root of a minus x square. Okay, I won't talk much. Since I have full pledge, I have taken polar coordinate system. In that sense, the radius will be 0 to a and theta will be 2 pi. How it is, that we will talk. Now the limit has changed. Theta is 0 to 2 pi and radius is 0 to a. And a by ar, so a outside, r by square root of a square minus r square dr d theta. If that is the case, then integration would be minus a square root of a square minus r square. Someone can compute. Okay, and limit of r is 0 to a. A if I place, then 0. Minus, so minus minus become plus and a and 0. 0 to a, right? 0. It will be a. A and a outside, a square. It will be a square. And then theta, d theta, 0 to 2 pi, 2 pi. 2 pi a square is the surface area of a sphere. Now, since this sphere is centered at the origin and x and y, we had started with x and y. So whatever we took, that is the top hemisphere. Now I have to multiply it by 2. 4 pi a square is the surface area of a sphere. Can someone see how big I'm really kind of, my head is spinning. Means how big pain we took to calculate the surface area of the sphere. Can someone see? First, we brought everything in x and y. Then we saw that I cannot do. Then we went with theta r coordinate system. And there we divided it. Then we calculated the Jacobian method of substitution. And then calculated the integration, changing the limit. And then I have just done the polar coordinate limit. But that is not the perfect way. Perfect way, x is minus a to a and y is minus a square root of a square minus x square to square root of a square minus x square. Then limit I have to change it accordingly. It is very tough. Okay. Now what is cross Jacobian? What is the integration what we are seeing? dp by dx cross dp by dy and its magnitude dx dy. This is the actual we are calculating. That is nothing but d surface area by dxy plane. Okay, that is equivalent to d surface area by dxy plane. dp by dx cross dp by dy is d surface area by dxy plane. Or if someone has problem here, I can just say dp by dxy plane. Makes sense, right? dp by dxy plane. dp by dx cross dp by dy is dp by dxy plane. But actually it is a cross b on the top. That is the surface area. So d surface area, I should be all right. D surface area by dxy plane into dx dy, dxy plane. Now this whatever is there, now I can rewrite as whatever is there into d theta r by d theta r plane. Anyone can write, right? D theta r by d theta r plane. If that is the case, then dxy plane and dxy plane cut down, and denominator d theta r will come here. So d surface area by d theta r into d theta r became like that. So D sir, this is our proof. It is not available in any of the book. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 +91 is the India country code. Please do support us. It helps. Anyway, now I have d surface area by d theta r into d theta r. Numerator d theta r I can rewrite as d, the way I did in xy plane, d theta into dr. D theta dr. What is d surface area by d theta r? That is under question mark. If d surface area by dxy plane is dp by dx cross dp by dy, now here it will come as dp by d theta into dp by dr. Okay, that is one. Second thing is what we are calculating. We are calculating surface area. We are calculating surface area. If we are calculating surface area of a sphere, and if I see a spherical coordinate system, then there are three independent variables. One is theta, okay, up, up, up. One is theta, okay. If I have a sphere at the center of the sphere, if I cut it, means if I have a sphere is centered at the origin. If a sphere is centered at the origin, then xy plane would cut at the center. Okay, if this is the sphere and it is centered at the origin, a blue color what is seen is the center, then it will come in center like this. It will go inside. If that is the case, if that is the case, it is centered at the origin. Now from center of this, now from the center of the sphere, the xy plane what we see on the xy plane, okay, there is a theta angle that spans 2 pi degree. Okay, if there is a vertical like this, then there is a pi angle that goes from here till pi angle. This is second independent variable. Third is the radius. Radius from 0 it will go till the surface of the sphere. So these are the three things. But now if I am calculating the surface area out of three, first is theta in xy plane. In xy plane, xy plane means not the passing through the origin, any xy plane, parallel to the xy plane. Theta angle would go 2 pi degree. Okay, phi from the vertical, it will go pi degree. Radius from 0 to a full plane. But radius, if I am talking about only a sphere surface area, not the volume, radius is constant, that is a. Two things that is variable is theta and phi. That is the two things that is variable. Okay, so rather than taking R, this is our proof. This is not available anywhere else. How to find surface area through cross Jacobian? First of all, cross Jacobian is the concept that we brought in. Now dp by dp. Now what is the independent component in a spherical coordinate system we are taking? Theta and phi. So instead of saying that d surface area by dxy plane into dxy plane into d theta r by d theta r, I am saying d theta phi by d theta phi. R we are not taking because it's a constant for the surface area, that is radius a, that is fixed. Dxy cut down, d surface area by d theta phi, that is this dp by d theta cross dp by d phi. Now, what is P? If I see, if I P it is still, I have not changed. It is still in xi plus yj plus zk. What is x in a spherical coordinate system? So dp by d theta cross dp by d theta cross dp by d phi. Whatever magnitude comes, d theta d phi. Now d theta d phi, I have to change this x and y limit, the circular limit, into d theta d phi. Okay, d theta d phi. So what is the dp by d theta? What is p? P is xi plus yj plus zk. What is x in a spherical coordinate? Probably next session I'll take. What is anyone knows that in a spherical coordinate system x is a a sine phi cos theta, y is a sine phi sine theta, and z is a cos phi, where a is the radius of the sphere. D a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k by d theta cross d a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k by d phi. Okay, so this someone has to cross it, but someone can directly go for the Jacobian. Someone could go directly. So Jacobian, I have to calculate the 3D determinant. So 3D determinant is first I can now write I, J and K. I, J and K in the first row of the matrix. And in next row I have to write dx by next row I have to write dx. I mean, I'm sorry, leave it determinant. Okay, just do direct cross. That is the pure way. I believe through determinant also that is the cleaner way. Okay, I believe determinant, if I say I, J, K, and then here the first row would come as dx by d theta, and d dx by d theta, dy by d theta, dz by d theta. Next row will come as dx by d phi, dy by d phi, dz by d phi. Okay, these are the two rows, and first row is ijk. Now this Jacobian will, if I calculate, it will come as a vector. Means the cross product of dp by d theta cross dp by d phi will come as a vector. Either someone can calculate directly, where dp by d theta, p is xi plus yj plus zk, x is a sine phi cos theta, y is a sine phi sine theta, z is a cos phi, dp by d theta cross dp by, or someone can put in a directly in the matrix. Now, if I see by d theta, the last component k, that is a cos phi, will become 0. So first will be a sine phi minus sine theta. Second component will be a sine phi cos theta. The differentiation of sine theta is cos theta. A cos phi, third term will become 0. Now in dp by d phi, it will become a cos phi cos theta. Jth term, second term will be a cos phi sine theta. And third term will be minus a cos minus a sine phi. That someone has to put in the matrix and silently calculate it. Whatever comes, then square it individually and a square root. Because whatever comes, okay, so whatever we are getting, dp by dx cross dp by dp by d theta cross dp by d phi, whatever we get, then we have to get, because we are calculating the surface area, right? In surface area, whatever we get with this calculation, I have to calculate the magnitude. Actually, I tried it personally, and it came as the cross, the Jacobian factor, that is dp by d theta cross dp by d phi. It is very simple, I, j and k. Next is dx by d theta, dx by d theta, that came as a sine phi minus sine theta. Another is a sine phi cos theta. Another is 0. That holds the key. It becomes very simple. And next row is a cos phi cos theta, a cos phi sin theta minus a sin phi. Now with I, j, k, someone can calculate immediately, because 1 is 0 and it come as a to the power, it come as, I believe, a square something it comes. Now whatever it comes, I, j, k factor, now I have to square it and a square root. If I square it, then it becomes a to the power 4 sine square phi. This is what I remember. Very quickly someone can get. a to the power 4 sine square phi square root a square sine phi it comes. A square sine phi directly we are getting, rather than first calculate getting everything in x and y. Then we think about that we have to use Jacobian in one go only, we are getting the result. Then it comes as a square sine phi, a square sine phi d theta d phi, simple. Now a square sine phi d phi, a square I can keep outside, sine phi d phi, sine phi d phi integration is minus cos phi. Phi from 0, phi is from 0 to pi, I have to take full, okay, for full. So 0 to pi minus cos phi, pi is minus 1 and 0 is 1, it will come as 2, 2a square. And d theta is theta integration 0 to 2 pi, 2 pi, 4 pi a square, quickly, not top hemisphere, not bottom hemisphere, nothing. 4 pi a square is the surface area of a sphere. We will do more work on it because we just took that x, y, z is a cos square, sine square, whatever we took. Second thing is limit. We just took that phi is 0 to pi and theta is 0 to 2 pi. So that we will see, and how we calculate Jacobian. Probably we'll end up with that discussion. This is what I would try. Very nice, right? So if I have to calculate the surface area, then directly I can use cross Jacobian. Cross Jacobian means dp by dx cross dp by dy dx dy. Instead of just write dp by d theta cross dp by d phi d theta d phi. Simple. So if I have something in vector form, highest form, that is algebraic vector, directly I can do through cross Jacobian. Okay, now in cross Jacobian, if this is xy plane and z surface is there, it is dependent upon xy plane, and xy plane is dependent upon theta phi plane. Xy plane we are taking it out. Now z is surface is directly dependent upon theta phi plane. Direct computation or cross Jacobian. This is our invention. Okay, cross Jacobian. If it is in vector form, directly someone can use cross Jacobian and it works. How cross Jacobian comes into the picture, how Jacobian comes into the picture, that we will talk. Please do support us. +91 is the India country code, 9483160610 is 0 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Email address someone can get in the description. Okay, so this is how it is. We will proceed on it.